It's okay.
All right. Michael, do you have your speaker on? Can you go turn that off so I'm not like echoing throughout the room? Okay. So we're going over Linux and Linux privilege escalation. So this is one of like 2 operating systems focused meetings. The next one next week will be on Windows. So the plan is real quick. Let's go to the overview first. To go over the like Linux operating system at a pretty high speed. So I'm assuming everyone here is already mostly familiar with this stuff. So I'll just go through that as a refresher, and then through a lot of like practical things I've seen that let you go escalate your privileges and get root on Linux machines, and then as well sometimes abuse trust relationships to go get root or just code execution on Linux machines that your machine talks to. That'll be the SSH hijacking example. So before we get into that, I'll go over the announcements. So we got a second team slot for Cyberforce approved, which is awesome. And it shouldn't really make a difference like which one you go on. Both teams should be, I think, pretty stacked in terms of people doing that. So go talk to Michael if that's something you're interested in, like going on the other team. If you're like kind of sort of interested, we also have like alternate slots we can put you in. And the deadline for that is October 3rd. So got to get on that like real soon. But again, if there's something you're interested in, just come to me or Michael after today's meeting. And then here's the meeting flag. If folks want to put it in. Slides should be uploaded, and this should be on Pwny CTF. If not, bug me about it, and I'll go make sure it's up. Okay. So I'm going to start off by just like speed running through like the basics of the Linux OS. A lot of this is going to be, I think, review. I'm just going to go over the permissions model, a little bit about shell scripts, cron jobs, services, and sudo, and then SSH. So all this should be, I think, pretty like foundational stuff. Okay. So if you open up like a VM or one of the Pwny OS boxes and do like a ls-l, it'll show you a bunch of permissions on the left with a listing that looks something like this, right? So, and I see this is exactly where Henry has trolled me because he went through and revised the slides and added a chmod 777 entry in Etsy Shadow. So if you know what that means, great. If not, yeah, that should have jumped out at me earlier. Okay, so on all the way to the left, it'll have, is it a directory or not? That's what the D bit is, which is pretty useful, but it's not really important for security. And then we'll have the permissions applying to the owner, right? So it's read, write, and then execute with an X. And that'll be those 3 bits. Then it'll be permissions applying to the same user group. So we can see we have like RWX for the one at the top, then for the one in the middle, we have nothing, right? So if you're not in that same user group, there's nothing you can do to interact with that file. And the last one is permissions applying to everyone else. So for the top entry, you can see people can't write to the directory, but they can go traverse it with the X bit and they can go read into it. You can't interact at all with the shellcode file, for example. And then because, you know, Henry decided to mess with me at the last minute, he edited the Etsy Shadow entry to go say anyone can read it or write to it, which would be disastrous. Does anyone know why that would be a disaster? Does anyone know what the Etsy Shadow file does? Yeah. Yes, the Etsy Shadow file stores your password hashes. So being able to write to this will net you immediate root on the machine because you just take a password you know, calculate the hash, write it in there, and do su root, and then you get root and you win. So that's just like a quick idea of why you want to be looking out for stuff like this. A configuration this blatant would almost never happen organically, but you will find things that are like 1 or 2 layers of indirection away that will let you kind of pivot like this. That's more common. And then the last thing is just who owns it as a user, who owns it as a group, and you can have users and groups be the same thing. It could be different, but a lot of times you just see it, they're the same. And then there are some special permissions. So I just kind of like went through that real quick because I'm assuming, are most people here loosely familiar with like the Linux file system and privileges model? Is anyone like not already exposed to that or comfortable with it? Okay. Yeah, so basically the danger with this, kind of like the Etsy Shadow example, is if you have something that's functioning at like a privileged level, and you have folks that have less privileges, right, that can write to it and modify it, there are some cases where that'll enable you to go get arbitrary code execution on the system or otherwise just cause damage to it. That's like the gist of it. So there are some special permissions that I wanted to go over real quick, at least the most relevant one. The first one is set user ID, which is when this is set, the file is always executed as if it's run by its owner user. So an example is if you do, I think it's chmod u plus s, that means, and you run it as root, then anyone who runs it even unprivileged will run your binary as root. And sometimes this is fine. There are other cases where it just immediately leads to you getting owned. And I'll go over that like practically later. SGID is like the exact same idea. Last thing I wanted to briefly touch on is file attributes. They're a little bit rare, but they can like really mess with you if you haven't seen it before. So you can do things like making files immutable, and the file attributes will override the actual permissions, right? So if you have a file that's set to be readable and writable by everyone, but you mark it as immutable, even if you write to it, even if you're root, it will not write because you've set the immutable portion of its file attribute. So this is something people will do all the time to quickly gain persistence in like King of the Hill, which is like a CTF where you have multiple people on one box, is they'll mark a file as immutable, and then they'll just remove every single binary on the box. It'll let you adjust file attributes, which is like a very classic, like cheesy technique folks will do to kind of go mess with you. So, but most commonly, it's the set user ID bit that can be abused in practice. And then if you want to use the chmod command to go change your permissions, it just follows octal syntax where it's 4 for read, 2 for write, and 1 for execute, and then you add them up. And then it should be in the order that I showed earlier, where it should be user, owner, group, and then everyone else. So if I wanted, hey, I'm the only one who can read and write, I could just do chmod 600, that's read plus write, and then 0, 0 for everyone else. So. And that's the common setting for something like an SSH key, right? Where you really don't want someone else to be reading your SSH keys. Okay, so kind of continuing with just going over the fundamentals. These are 4 like essential components of the Linux OS that you're going to be using all the time. And these are like the most common, I should put services here as well, the most common things you can look at to abuse for escalating your privileges. So the root user has complete control over the system, right? Root is like God mode. You can edit the kernel, you can write to any file, you can write to any program, you can do pretty much anything you want. And sudo lets you run commands as another user, which is usually root. So sudo is a write. You need root permissions to go give it to someone else, and it's in the etc sudoers file. And a user can check, hey, can I run sudo on this machine with sudo-l? Usually, this will require your password. So if you've gotten on a box and you don't have a password, then you're just out of luck. But if no password is set, then it doesn't. And no password can sometimes be very, very dangerous because it'll let you just any context where you have code execution, you use sudo with no password, and then just run stuff. So in this case, right, this is very dangerous. This user can run all commands on all hosts as all users with no password, right? So I can ask, like, do you guys have any guesses why this is a bad idea for assigning privileges in this way? I think it should be, pretty much immediately jump out at you. Exactly. Yep, so there's no like boundary here, right? Like if it was like, hey, you can run whatever you want, but you need to know the password. As long as the password is exposed somewhere, that might actually present an attacker like a pretty significant hurdle to get over. But if you can just run whatever you want with no password, you are functionally, there's no boundary, right, from where you are to getting root. You're just already there. So yeah, this really is not like segregating the permissions in a meaningful way. This is identical in effect to just running the program as root, right? So outside of sudo to go run things as root, there's also su for switch user. I think that's what it stands for. And one like just small caveat, at least that got me when I was like getting into CTFs, I didn't know this stuff. 9 times out of 10, if you want to become root, you do sudo su, not su root. The difference is sudo su will turn you into root with your password as sudoer, whereas su root will require the root password. And you'll see very commonly, like people will not be putting root passwords on their boxes. They'll do it through sudo instead. And the other thing is you can view all of the users in the box by reading a file called SIGPwny. This is world readable. Interestingly, SIGPwny does not have any passwords in it. It's kind of a misnomer. I believe it used to a while ago, and then it got separated where they moved it to the shadow file because the assumption was, you can't crack hashes even if you read them, and that assumption was incorrect because if people have weak passwords, you can just read it and crack the hash and go escalate your privileges. So that's why that's separated out. And then Etsy Shadow is now not world readable. You have to be root to even read that file. The other thing is shell scripts. I'm assuming everyone here has probably at least like touched or written a shell script before. They can be really, really simple or very complicated. And a lot of times you can use it for things like installs, but sometimes you'll see them being used administratively. So I'll go over in a second cron jobs and services. Those are sometimes common more for cron jobs to be running shell scripts. One practical note that's like very, very important that I've seen more than a couple times is if you have a box that's a Linux box and it's talking to other things like databases, right? A lot of times to log in, they'll use some command line utility and then pass the parameters like in the shell script they're doing to run that. So, you know, even if you can't immediately escalate your privileges, you could have exposed credentials that let you gain access to some sort of like adjacent service. So that's a pretty big deal. Right, especially if that other service has any kind of additional outbound access control, you can keep like working your way through a network with something like that. And the most common case I've seen this is when you have a remote database, especially one that's connected to a web server. That is like the most common thing that I've seen. The other thing is we have write access to a shell script that anyone else is running. That's an easy win. This is a pretty rare misconfiguration in a lot of cases. It's like pretty flagrantly bad. Right, like a lot of folks with system experience wouldn't be making a mistake like that, but not everyone, right? So it's worth checking for regardless. Cron jobs are just scheduled tasks, but for Linux. They can be in a bunch of different places. I think it depends on your distro, but I'm not certain because I'm not an expert on how Linux like sets this up. So a lot of times, right, you should be able to read these. And the asterisk will signify how they run. So I should have included a picture here. I didn't. I'll have more pictures later. But that'll be how often is this script executing on its own. So what's important about this is if you have something where it's privileged and it's running on like a set amount of time, right? Every 5 minutes we're going to go run this script. If you have the ability at all to mess with the script, right? If the ACLs are set wrong and you can write to it, well, you just wait and then you get arbitrary command execution, right? That's a pretty easy win. There's some other like dirty tricks you can pull if they have like wildcards in them, right? Because Bash will do things with wildcard expansion. So if you know, hey, it's running something related to a wildcard in a directory I control, you can sometimes, depending on the program, name files in a very peculiar way that'll actually result in arbitrary command execution. So even if you don't have direct write access over it, there are still occasionally abuse cases that'll enable this sort of thing. Yes, up.
Can you elaborate on getting command executions from naming files? Does that sound?
I didn't have a slide for it, but go Google tar wildcard exploit, and that should give you an example of like the most common one. It was like an old like OSCP challenge they put you through. Okay. So just quickly moving on, SSH, I think everyone here is going to be loosely familiar with SSH. It is actually secure, like for the most part. It is still very useful for attackers though, because as a feature, right, if something's running SSH, we have a valid password, we can go get in and run commands on that box. And that's actually a very, very useful like primitive as an attacker, right? If I get a bunch of credentials, I could try to SSH in and own more boxes. The syntax is very simple. It's SSH user at host. You can do other things as well, like with port forwarding and networking with SSH. But SSH is very, very useful as an attacker for lateral movement because this is like the intended way to go interact with the system. You're not doing anything like kind of strange like psexec on Windows, which I'll go over later. So there are 2 ways mainly to go SSH into a computer. You can do username or password, or you can do a public-private key. This is important when you land on a machine because you want to be looking out for any exposed SSH keys. They'll usually be called ID RSA or ID ED25519, right? And of course, even though it's rare, if you can go grab anybody else's SSH key other than yourself as an attacker, that's a huge win, right? Because that might get you more access to your current box or to some other adjacent machine. So it's always worth looking for these. And there have been persistent issues with people not properly securing their SSH keys and not encrypting them. Like this is something you will see a lot if you are not in a place that forces people to manage their SSH keys. right? So the other thing is, when using your SSH client, it will usually, to try to prevent this kind of silliness, force you to do chmod 600 to SSH. In other words, will yell at you and be like, hey, your private key permissions are set incorrectly. If you want to be able to use this, you have to correct it. But of course, users are sometimes very persistent about circumventing things designed for their own safety. So this is, again, also useful if you have some kind of like file read primitive and you're like, how do I turn this into code execution? If you luck out, you could try to grab an SSH key. In practice, you probably wouldn't see that through like a web app. It'll happen sometimes, right? But if you have like a directory permission set wrong or anything like that, and you're like, how do I turn an arbitrary file read into potentially command execution? This is a pretty good guess, at least, to go try and go look for that, if you know what users are on the box. All right. So speed running through it. Does anyone have any like just fundamental questions before I get into the actual most common techniques to go like escalate privileges? No? Okay, awesome. So this, I'm putting this here, even though kernel exploits are complicated, almost every single Linux box I've landed on that's vulnerable to something, like any one of them on this list, is also vulnerable to this. So you can land a Linux system and then start checking the OS version with uname-a, or you can do cat/etc/os release, and then you can start Googling or searching exploitdb for known exploits on your Linux kernel, or you can use a tool called linpeas, which I'll get into later. But there is one very, very, very important exploit, which is PwnKit. So this is a stable kernel exploit that exploits an issue, I think, with polkit and sudo, so you just get root. And this came out in late 2021. So I remember I started hacking in like early 2022, and every single box I landed on, you could just run this. But even to this day, right, if folks are not like required by an enterprise to go run apt-get update like every so often, it is very common to go land on a server and be like, oh no, it's Ubuntu 16, and then you just run this in 2 lines and you own it. So my fun story about this is last spring, SIGPwny with their Bitwarden lost some of their SSH keys. I don't know how this happened. I didn't get any context on it, but Cameron was like, hey, Ronan, we lost some credentials. Can you go recover stuff for us? And Henry and I were like, yeah, I'll do it. And we had like some SSH keys. We can get an unprivileged. So we're like, oh, surely, SIGPwny, we're the security club, right? We're going to be security conscious. I think we got into 4 of these. Every single one of them were vulnerable to PwnKit. So I just went in, got root, dropped a rootkit, apt updated, reset the passwords, uninstalled, that was it, right? And again, almost every single Linux server that's going to be vulnerable to something may be vulnerable to this. It's just a security hygiene thing, right? So you're not being proactive to go update this. This will happen by default over time. And just as a human tendency, right, a lot of folks are not going to stray from default. So, if there's any one technique to take away from this, it's to check for this specific kernel exploit. Dirty Cow is like the old version of this, but that was like a 2015 era thing, and that's become much, much rarer. So yeah, this is a very like practical method that you'll see a lot. All right, SUID. This one is a little bit less common, but it still does happen. Which is, when you set the SUID bit right, anyone can run them as root. There are a lot of binaries where it is absolutely not safe to do that. Like there's a huge list of them on a website called GTFOpens, which is an absolute classic for folks doing like CTF, like OSCP or anything like that. Right, and there are things that might surprise you. Like for example, if you have sudo on Vim, outside just like the file read and write, you can also just use like !! And start running whatever commands you want, right? So there's a lot of like weird features in some of the Unix like standard files like user bin that'll let you escape and go run arbitrary commands, sort of like a local version of command injection. So this is a pretty easy way to go escalate your privileges. It's going to be very common in like beginner level boot to root CTFs. It happens a little bit in real life, not a lot. And then it's really easy to go enumerate these. You can just run this command, which is basically just going to be looking for set user ID files on the system. And some of these are going to be totally secure, like normally. I think there are a number of Linux utilities that'll have these. I think password is one of them, where it'll just be like, SUID. But there are a lot of them that are unsafe. So you can just start to quickly memorize, be like, hey, that's not a normal thing to have the SUID bit set. Can I abuse this? And if so, it's going to be like 2 minutes until you get roots. It's pretty easy. So the goal is to find binaries that can either modify the system state, let's say like write to a privileged file or like read etc shadow or something like that, or just run commands, right? If you can run commands, you win, and that's pretty easy. The other thing is if you exploit sudo no password, right? So some of these is gonna be really easy. It's just like, hey, I can run all. The other thing is like there are sometimes it'll be more granular, right? You can set an access control where it's like, hey, they can only run like 2 binaries as sudo. But just like the set user ID, right? If it's a binary that you can escape to run whatever other command, then just transitively you can run anything as root. So it's like the exact same set of like exploitation steps for both of these things, right? They're the exact same like primitive as an attacker, right? I can run something and maybe I can cause input that'll let me go run something else of my choice to just get root on the box. Yeah. Oh, yeah, that's another thing. Check the access controls of the binaries you'll be allowed to go run. Because sometimes they'll be like, hey, you can run some like specific script, right? That's designed to like back something up that requires root to go read it. Great. Well, if you can write to that, you just, add something else to the end of it that gives you a reverse shell and run it, and now you have reverse shell as root. That's sort of like the gist of both of these vulnerabilities. Okay. This is a fairly similar idea to things we've gone over before, which is expose vulnerable files. So if you find exposed script you can write to that belongs to anyone else, you can just overwrite that to run whatever commands you want. So a very common one is to just, run a reverse shell and background it so you don't like destroy whatever the original functionality is. But another like more common win is to go look around for any kind of exposed credentials. Like this is very, very common, again, when you're interacting with databases. Yeah. Okay, so this is the dedicated slide on Etsy Password and Etsy Shadow, although I touched on it a little bit before. So Etsy Password has a list of users and Etsy Shadow has their password hashes. So if you have write access to Etsy Shadow, this is how you become root. You just use OpenSSL with those command line parameters to go generate a hash the system recognizes. And then you can just like echo that to the end and create a new user, or you could just vim it and like replace the root hash with that, and then su root and type in like whatever password. So it's with pwn in that instance, right? But anytime you have write access to the shadow file, you become root. The other thing is, let's say you already get root and you're like, hey, I want to go crack the passwords on this box because say, we're joined into like Active Directory, right? And I want to be able to see, can I use this user context, right, to go get a valid login somewhere else? So you want to go crack those hashes and recover the initial password, right? So for folks that aren't familiar, hash cracking is the idea where you can't turn a hash backwards, right? It's a one-way function. What we can do is we can just try everything. And you can be decently smart about this, like take a word list from like a data breach and then apply some permutations and combinations to it and use that as your list of things you're going to try. That way you can bring it down to like, in the 100 million, 10 billion range of like things you're going to try instead of however many letters like permuted, right? And you can go run that to try to recover the original like plain text password. Usually you will need a very strong GPU to do this. This is actually the reason I bought a laptop with a 5090 in it, was explicitly for that. I know like a CTF, I think a week or two ago, we rented like a bunch of GPUs to go do something similar to this, to go crack a desk key. This is a pretty common practice. And if you want to go do this to just start cracking the actual user passwords, there's an old tool called John the Ripper. And John the Ripper was like the original password cracking tool. And it came with a utility called unshadow, which is where you take the password and shadow file and you run them through this tool and you'll spit out something that John the Ripper can go crack. And then the more common thing that's used today is called Hashcat, which is a GPU optimized password cracking utility. So all you do is you just cat or download these files, unshadow into something called CrackMe, and then you just pass the right parameters to Hashcat or John the Ripper, and you're off to the races. And if there's a weak password, you should be able to recover it within a reasonable amount of time, like definitely less than a day. Yeah, and this is the actual command here for both John the Ripper and for Hashcat. You can also get really, really fancy in terms of the word list that you try. It really depends, right? Like usually you would try to see what the password policy is and then brute force something within those constraints to be optimal. But you can look into like rules, which are permutations and combinations. You can do a raw brute force up to a certain length, which is generally only going to be viable if you have access to like a supercomputer. And then you can do key mapping. which is a pretty interesting one where you exploit common things where folks will do like 1 QAZ, 2 WSX, right, on like a QWERTY keyboard and just like run their fingers in a line, or like month-year type passwords, right? These are all things you can go try. It's like post-exploitation steps. So we're getting towards the end here, but this is a very easy cheat sheet of things to go check for, of like, these are easy wins, right? So hosting just what the box called, ID is like, who am I running as? Cat etc password gets you the users in the box. Uname A is what kernel I'm running. PS auxf is list me all the processes that are running and tell me, who's related to what in a forest format. That's for IPA, just shows you your available interfaces. This is important because sometimes you will be in a box where you can access multiple networks, and that's important. Route for the exact same reason. SS-amp will show you network connections that are actively open, which can also reveal, like, do you have like apps, like do you have like a web server running only on like localhost, and you have to like tunnel in to go access it, because that's sometimes possible. Like an example of this just recently, I saw like an open PLC on localhost, which can be abused to go run arbitrary code, and then you tunnel in, you can set stuff to that. You can LSLAH the cron tab, right, with or do cron tab-l or look in syslog for cron, right? Dpackage-l if you're on a distro that supports that, let you look at installed applications. The find command should show you like writable files. Mount shows things you have mounted. I don't remember what fstab does, actually. It's been a long time since I've done that. lsblock will show you, I believe, your disks. lsmod will show you loaded kernel modules, and then you can do sbin-mod info to go check. If it's like you could just check for like driver vulnerabilities the same way you would check for any other vulnerable piece of software or kernel exploit or anything like that. So that's why you would check. Drivers will sometimes present like unusual paths to root. I think that's much more common on Windows systems than on Linux ones, but it's still worth checking. And the last one is just the setuid bit checker, which just says, hey, find me all the setuid files on the system. So now that's a lot to remember. So you can instead just use this. This is the Linux privilege escalation awesome script. I'm going to put a few caveats on this. Like when you're learning, this is a really cool tool because it'll just automate all of the checks and then link you like a blog post of how to run the attack all in one shot. And it will highlight it like with the background, like literally with the highlighter, be like, hey, you need to go exploit this to go get root. And you can really easily, we have this pre-installed in the Pwny OS boxes. Just go to your tools directory, do python 3-m http.server to go run a server, and then the victim box, you just curl it and type it into bash. Issue is the reason you don't see like real bad guys using this will make it abundantly clear that you are attacking someone. This is as unstealthy as it gets. This is like 7,000 lines of doing overtly malicious things. It will leave behind artifacts. It will be forensically very, very obvious. So this is pretty much like for CTFs only, right? Not for like actual use, but it's really cool. And it'll show you things that you would almost never be able to go check for by hand. Because this thing is like a giant database almost of the most common vulnerabilities with links to exploit them. So it's a very cool tool. This is what it looks like, and I didn't show the output because it gets very, very long. But on like the Pwny OS box and the CTF, you just host it from your tools directory, and you curl it down and pipe it into your shell. So you need to go write it to disk. And then it'll go show you a bunch of like highlighted output and stuff. So that is like the basics of very common ways to go get root. And those are like one and done techniques. You can more or less just go copy them. Now I want to talk about something a little bit more theoretical, but it's something you'll see a lot in real world networks. And that's the concept of abusing trust, right? So my sort of example for this is an attack you can pull off called SSH hijacking. But there's a lot of context where you can adapt this sort of situation to something else. So this is like a real scenario that actually like has occurred where you'll usually have a restricted network, right? It's for some context. And then you'll have a box in the middle where folks on your unrestricted network will need to go through it to access your restricted network. It's a very, very common configuration. A lot of times people call it a jump box. So there are a couple things that folks will run on these jump boxes that will go make it really easy for a normal user. Just go connect through it, right? So we're going to SSH onto the target host. We don't really care about the jump box. So you'll connect through it. and it'll appear as if you just go straight to the target host, right? It's magic, it's cool, but nothing is actually magic at the end of the day. So the issue is, if an attacker gets onto the jump box, right? And let's say they get root on the jump box, they're like, hey, I don't have any credentials, I can't move anywhere, I can't get in the target host, I can't get in the normal user, I'm stuck, right? Well, one really neat trick you can do, if it's an SSH server, it's a jump box, and it's this frequent point that people are going to be passing through to access this privileged location. And since you are root and you can compromise all of the information that flows through this box, is you can do a technique called SSH hijacking, where you wait for someone to connect into you, and then you know they have all the information you need to give them a valid login on that target, so you just take it over, right? And you can use this to straight up take over an existing SSH connection. So the idea is, if we're the jump box and we own the jump box, and somebody is going to SSH into the target host through the jump box, then we own any target that anyone's going to SSH into from that point on. And this is like a pretty crazy powerful technique, right? Because it's not just SSH that this applies to. This applies to anything where you have one centralized place that a lot of people interact with that touches other things. So think like a GitLab repository, right? You have the ability to push artifacts to hundreds or thousands of hosts, right? It's like the exact same principle that applies to like a supply chain attack. So.
Got a question?
Yeah, what's up?
So how do you circumvent the SSH fingerprinting mechanism? Because isn't that like designed to stop exactly what you were talking about?
So this is because this is a scenario where people are supposed to be going through the jump box. So to make this clearer, because I was talking about like explicit software, I just do this manually because I actually have a jump box at my work that I have to do this through. It's like it's a real configuration. So the normal thing is you will be like the key you're remembering is for the jump box, and then you'll SSH into the jump box, and then from the jump box you'll SSH into the target. Right, that's how it would look if there was no software. And then the thing I was talking about or showed earlier, which is SSH agent and control master, they just automate this process. But at the end of the day, this is what they're doing under the hood. Does that kind of make sense? So the key that you're thinking about the fingerprinting mechanism is the normal user is going to be recognizing that jump box, but they have to like authorize the jump box and the target ahead of time. So if I go back to the command line for the that, right? You see user at jump box, user at target. When you're doing it, like that box is going to recognize both of those as legitimate, if that makes sense. So this is abusing something that you're already doing, but like there's not a mitigation for this because it's just assumed if somebody compromises the jump box, they can hit it downstream.
Yeah, I saw like somebody was trying to impersonate.
Yeah, so you're not impersonating. Like you are the legitimate jump box. You've just owned it. So you're going to go own things that pass through you. Yeah. No, that's a good catch, actually. So control master and SSH agent are examples, and these are things where you can look for a config. I think, honestly, the most interesting and common case is when you don't have software doing this. So I'm probably just going to skip through these because it's all the same technique. But for these, you can like literally just run the SSH command. There's no tool, there's no fancy exploit. It's just if this happens and somebody SSHs through you into the target, you as the intermediary can just SSH into the target. No password needed. And that's it. That's the entire exploit technique. This one is very, very interesting and has been used for real, right? So this is a case where what if we don't have software to do this and we have a jump box? So we just SSH to the one, SSH in the other, right? And maybe as users, we're doing some kind of port forwarding, we're just getting a shell on that target host, right? How could we go compromise that essential information? Well, in this case, because people are entering a password, right? If you use a key, it'll be a little bit different. But if they're running a password, because we own all of the information that passes through the jump box, we can use something like strace, which will just read syscall results and go attach strace to the SSH process, right, of the user who logged in. And then when they try to SSH into the target, this will enable reading basically, I think it'll be all of their keystrokes, but most importantly, the actual SSH password. So this is like a really easy way where if you're an attacker, you can just go sit on this box for like a day or two, and then just farm logins with strace and wait until you get someone really privileged. But this is like a really like neat, very evil trick because there's no inherent vulnerability here, right? This will come up on like a network scan, or even thinking about it, this probably looks fine. But this is an important assumption where we establish a trust relationship with target host, kind of like the credentials needed to access target host must go through the jump box. So that gives us a single point of failure that can have pretty disastrous consequences. Like the S-trace trick, even though it's simple, this can be done like to great effect. How's that, guys?
So you need to compromise, like, you need to be on the jump box, basically.
Yeah, this would be you have root on the jump box and you can't get into anywhere else at the moment, and use S-trace to go farm things that go from the normal user to the target box, if that makes sense.
Over here, since you control SSH from the jump box to the target, does a normal user still like SSH to the target, or is it like somehow blocked?
Can you say that one more time?
Since you are controlling the jump box to the target, does a normal user still SSH to the target, or is it like intercepted?
It depends on the technique you use. If you do the S-trace thing, I drew a second arrow because you'll be running SSH again. For these other two, I actually don't know because I have not been able to observe what it looks like to the user because I've been on the jump box. And it's like, I can only see what it looks like to the jump box. So from my perspective, I get a seamless SSH login by just typing SSH. I have no idea what it looked like. So I could have just kicked the user out. Honestly, I don't know because I wasn't on their computer when I was doing it. But this case is much simpler, and I think illustrates the point in a more common way anyway. So it's not a lot of folks are going to be using, like, it's nice if they have automated SSH agents to go like make this stuff easier, but it's not always the case. All right, so that was like basically my speed run crash course on the most common ways of getting root on like Linux machines. And then we're gonna be kind of following the same like schedule for the next 2 weeks where we go over how do you detect stuff like this on a Linux box. And then I'm gonna go in much more depth on Windows and the Windows OS. That's like my thing, my area of expertise on Tuesday. And then we'll get into Windows forensics. So before I call it there, does anyone have any like questions on anything I went over, anything else, anything related to like training? All right. Well, thanks for coming, guys. I know, everyone here will probably have a long day of listening to folks like lecturing you. So I appreciate taking the time to show up and do this. So